What's going on, guys? Let's try this problem right here. This question is asking a spherical non-conducting cell of inner radius r1 is equal to 8.4 centimeter and outer radius is equal to 16.8 centimeter carries a total charge q is equal to 15 microcoulomb distributed uniformly throughout the volume of the shell. What is the magnitude of the electric field at a distance of r is equal to 13.4 centimeter from the center of the shell? Now let's see how we can figure it out. And here we are trying to find the magnitude of the electric field at a distance of r is equal to 13.4 centimeter. Now let's list all the given informations. First we have the r1 that is equal to 8.4 centimeter, and we have the r2 that is equal to 16.8 centimeter, and then we have the charge that is q that is equal to 15 microcoulomb, and then we have the distance we are trying to find, the electric field at the distance we are trying to find, that is r, that is 13.4 centimeter, right? Now the first thing we are going to do is we are going to find the charge density, because in that way everything will become easier. Also we have the k value. Let's note that one down. K is equal to 8.99 times 10 to the power of 9 Newton meter square per coulomb square. Now first we are trying to find the charge density. Let's call charge density sigma. Sigma is equal to q over the volume, right? And q here is going to be 15 microcoulomb, 15 times 10 to the power minus 6 coulomb divided by the volume. And since we are dealing with a spherical shape, the volume is going to be 4 by 3 pi r cube. So this is going to be 4 by 3 pi r cube, and the inner radius of this shell is going to be this one, right? That is 8.4, and the outer radius is 16.8. So the shell volume is going to be just 16.8, but let's put this one in meter. This is in centimeter, so if I convert this one into meter, that's going to become 0.168 cube minus the inner radius is 80.4, so that's going to be 0.084 cube, and that's meter cube, right? This is meter cube, and if you calculate this one, you should get 8.63 times 10 to the power of minus 4 coulombs per meter cube. So this is our charge density. Now we are trying to find the electric field. Now what we can do is we can find another relationship between electric field and this charge actually. So the relationship can be formed by using electric flux equation. If you remember that electric flux is equal to charge over the epsilon naught, right? And also another electric flux equation, that is electric flux is equal to E times A. Now this is surface area, and we are going to equate both of them. So E times surface area is equal to Q over epsilon naught. And let's see how we can apply this one right here. So first, E times the surface area for a spherical shape is going to be 4 pi r square, 4 pi r square, and the distance we are interested in is this distance, that's 13.4 centimeter. And if we convert this one into meter, that's going to become just 0.134 meter square. That's going to be equivalent to charge. And here what we are going to do is, if we multiply the volume by the charge density, that's going to give us a charge in the particular volume, right? So that's what I'm going to do right here. So this is going to, we know that volume of a sphere is 4 by 3 pi r square, so pi r cube, 4 by 3 pi r cube. So 5 times, you know what, we are going to lack in space, so it's better to write this one like this lengthily, so then we can do the simplification, right? So I'm going to write this part in the bottom. E times the surface area is going to be 4 pi r square, 4 pi r square, and the radius we are interested in is this radius, that is 0.134 in meter square, and then that is equivalent to Q, and we know that Q is going to be the volume times the charge density, right? So volume times the charge density is going to be, volume of the sphere is 4 by 3 pi r cube, and the outer radius now we are looking at is this outer radius, that is 13.4 centimeter. but in meter that's going to be 0.134 cube minus inner radius is going to be same, that's going to be 0.084 cube, and then we have to multiply this one by charge density to get the charge. So charge density we found out that's 8.63 times 10 to the power of minus 4, and then finally we have to divide this one by epsilon naught, and the epsilon naught value is 8.854 times 10 to the power of minus 12, and that's it. Now let's continue this one right here. Okay, now let's simplify everything. So E times, if you calculate this value you should get 0.22564. okay, this value is 0.22564, that's going to be equivalent to this value. That's, if you calculate this value you should get 740,377.9887, right? So this is our value for this one, therefore E is going to be equal to this over this, 740,377.9887 over 0.22564, and if you calculate this electric field you will end up with 3.28 times 10 to the power of 6 Newton per Coulomb, and that's going to be our final answer. I hope this helps. Thanks for watching.